to know what determinants are in order to use Cramer's rule. And so that's what we're exploring today. The determinant of a matrix. So here's our definition. It's a number, and we find that number by subtracting the sum of the products of all of the diagonals going up on your matrix from the sum of all the products of the diagonals going down. And I'll explain that to you in an example. It's easier to see when you have actual matrix to look at. So here's your next screen that I want you to copy, and we'll go over more specifically what this definition means. So here's the next screen if you're hand copying. We're going to do a determinant of a 2 by 2 matrix and then a determinant of a 3 by 3. Sophia. Thank you. You're welcome. All right, so there's a few things going on in this screen. The upper half of the screen, like above this dashed line, is the general form for determinant, and the bottom half is a specific example. And here's the things I want to point out from the general example that's above the dotted line. There's two different ways here of identifying that we're talking about a determinant. This is one way. We can just have a matrix, the ABCD matrix, and write the letters DET out front. That's one way of saying I want to find the determinant of that 2 by 2 matrix. Another way is this one. This is a second way, where we just have the entries the same, but we put straight lines around it. Okay, that if you see that, that's also telling you you need to find the determinant of the matrix ABCD. Two different notations mean the same thing. And the way you find the determinant of a 2 by 2 matrix is you multiply, and I'm going to use the words from the definition, okay? The products of the diagonals going down. So this is the diagonal that goes down. So when you multiply those together, you get AD. So that's the down products. Minus the product of the diagonals going up. So starting from the bottom and going up on a diagonal is C times B. Okay, so you're going to take the diagonal going down, starting upper left, going down to the bottom right, multiply those, subtract the up diagonal. So it's the down products minus the up products. And we're going to do that for this specific example with my 2 by 2 matrix 3, -1, 5, 4. So the down diagonal goes like this. So it's going to be 3 times 4. And I'm going to subtract the up diagonal product, 5 times -1. So 5 times -1 is -5. 3 times 4 is 12. And I'm subtracting those two things, right? So I have 12 minus -5. Minus negative is the same as plus a positive. So this gives me 17. And there is some context to this that we usually talk about. I feel guilty not sharing it with you, but I don't want to confuse you because we're cutting out a couple lessons about this. But just know that this number 17, even though we're not doing anything with it today, we will be using it in Monday's lesson.
I have a question. So the -5 becomes +5. Is that because of the negative and the other?
Yeah, because we're subtracting the negative.
Oh, yeah, yep. I couldn't tell if those dashes were negatives or if it was like a divider.
Oh, no, it's a minus.
Okay.
No, I could see that. All right, so that's how to do a 2 by 2 one. That's pretty straightforward. But we're going to level up a little bit and do a 3 by 3 one. Does anybody need the screen up anymore or have a question about it? I feel like I want to just make up one more example for us to do before we move to the next screen. No, it's not on the quiz. The quiz is just on last week's stuff. Try this example on your own. I'm just going to give you a random. Find the determinant of that 2 by 2 matrix. Which two numbers are on the down diagonal? 2 and 8, right? So the down diagonal is 2 and 8, so I'm going to multiply those. Minus the two numbers that are on the up diagonal, 6 times 4. So that's 16 minus 64. 48 negative. And I had a question. Oh, you see, okay. There's a question in the chat, but then they figured it out. All right. Oh, no, it's not 64. If you put 6 next to 4, it's 64. I think that's what I did. But it's 24. Thank you. Okay, so any questions about how to find a 2 by 2 determinant? All right, then we're going to do 3 by 3, and then that's our lesson for the day. All right, I'll give you a minute to copy this general form down for those of you copying by hand. All right, so this one looks different, okay? We have a 3x3 matrix, A, B, C, D, E, F, G, H, I. But the problem comes in when we try to find diagonals. If I were to do what we did in the last, the only diagonals I have are A, E, I, and G, E, C. But the problem is if I were to go subtract those, I wouldn't take into account those leftover letters, the B, F, H, and D. And so here's how mathematicians have defined a determinant for a 3x3. What you do is copy down your original 3x3. So that part I'm talking about is right here. So this is how it was originally. And then look what's written right here. On the outside of that, look at this column, ADG. That's the same as the first column, right? So what we're going to do is copy that first column on the outside there, and also copy the second column on the outside. We're literally just going to write them alongside the original matrix. What that lets us do is now make multiple diagonals so we can catch all the letters. All right, so remember that it's the down diagonals minus the up. So down going from the upper left to the bottom right. So here's one diagonal, A, E, I. You see that's right here. The next diagonal is B, F, G, which is right here. And the next diagonal is C, D, H, which is right here. And we're going to add all of those up. And that's going to give me one number. So that's the down. Let's add up the down product, the down diagonals. And then you find all of the up diagonals. Now, when I take this very first up diagonal right here, GEC, notice how the D, I missed it, like the D in that first column hasn't been used yet. That's why we copied the columns over on the right, because I'm going to pick up that D here in just a minute. My next up diagonal goes like this, HFA, which is right there in our formula. And then here's where I pick up the D, IDB, right there. So we're going to add up the up diagonals. And then once we have those two numbers, we subtract them. So it's still down minus up. There's just more involved this time. There's more than one diagonal. There's 3 diagonals now in each direction instead of 1 like the 2x2. And we're going to do one example of this and we're going to be all done. But does anybody need the screen up anymore? All right, so here's a specific example. So your first step is that we're going to write columns 1 and 2 on the right side, on the right of the matrix. Yes, Kat. Oh, dang it. So you missed everything I just talked about on that last one? That's an unfortunate series of events. So you missed all this? I'm going to go over it again on the screen. So your first step is to write columns 1 and 2 on the right of the matrix. So the first column is 3, 1, 2. And the second column is -1, 4, 3. And we're going to do the downs minus the ups. So here's the first down diagonal, is right here. 3, 4, 5. You want to multiply those three things together. Now I'm not going to actually find the number right now. I'm just going to write it down. 3, 4, 5. Because we're going to add that to the next down diagonal. So that was down. Here's the next down one. So that's -1 times 6 times 2. And we're going to add that to the next down diagonal, which is this one. Two, 1, and 3. So let's go ahead and do that before we talk about the up diagonals. That's 3 times 4 times 5 is 60. -1 times 6 times 2 is -12. 2 times 1 times 3 is 6. And then -12 and 6 is -6 from 60 is 54. And then we're going to subtract the up diagonals. So to start with those, I'm going to go now to the bottom left corner from the beginning. And that first diagonal is right here. Right, we go bottom left, upper right, and then we multiply those three things together. So 2 times 4 times 2. The next up diagonal is 3 times 6 times 3. I'm going to add it to the one before. And then the last diagonal, 5 times 1 times -1. And so then we just do that math. 2 times 4 times 2 is 16. 3 times 3 is 9 times 6 is 54. And then we have -5. 16 and 54 is 70 minus 5, 65. And then when you subtract those two things, you have -11. And that's how you find determinants, which we will use on Monday's lesson when we use Cramer's rule, to something called Cramer's rule, to solve a system. But any questions about this before I shut down the Smart Notebook? Okay. The notes you need for your quiz are everything from last week. So it's lessons 1, 2, and 3. So take a few minutes. You can use your notes, you can use your homework, but no solving programs.